Hey guys, welcome to the Junior Astrophysicist. This is Akash, and in this video we're going to be taking a look at the Big Bang. So let's begin. Firstly, the Big Bang is not an explosion, but the Big Bang theory tells us how the universe might have begun. I cannot really say that we know for sure how the universe began, but it's only a chance, a true possibility. Let's begin. Today, the universe is expanding rapidly. Before we go deeper, let's look at the expansion of the universe, because the expansion of the universe is one way we can predict the Big Bang. So as the universe is expanding, stars and galaxies are moving away from us, and the wavelength of light is stretched as the distance is higher and the galaxy or star is redshifted, or light is shifted to the red end of the electromagnetic spectrum. The redshift of a galaxy or star is directly proportional to its distance from us, because the redshift is the shift of the light and it is proportional to the distance from us. Okay? So now we know that the universe is expanding regularly and rapidly. So if we go back in time, the universe will be contracting. So if this is point A, and time B, the universe is going like this, it's expanding. But if we go from time B to time A, the universe is going to get contracting. So at a certain point of time, the universe would have been very tiny. So let's say the state of an atom or a quantum particle, at which it's the most tiniest state, and it cannot go further tinier than that. So now we have found the appearance of the universe in the Big Bang. The appearance, it was very tiny. It's like we can't even see it. It's not even this size, it's not this size, it's very, very tiny. We can't see it, something like an atom, okay? So now let's imagine its temperature, the conditions of it. Well, there's something called cosmic microwave background, or CMB. As the universe expanded and wavelength of all waves in space stretched, the energy got reduced, because we know that when the wavelength is larger, the energy is smaller. And when the wavelength is shorter, the energy is larger. So the energy got reduced and the CMB's energy got cooled down. So the CMB's energy you can consider as heat energy. So it got cooled down as time passed, and is cooling down even now. So as the universe is expanding now, the CMB is cooling down now. So now again, let's go back in time. If we say this is time A and time B, it is cooling down from A to B. But if we're going from B to A, it is heating up. So at a very certain period of time, the universe energy, or the CMB's energy, would have been very, very high or large, and its temperature would have been very hot. So now we can say that once the particle was very tiny and it was ultra dense and it was very hot. That is the description of that particle before the Big Bang. So in specific terms or scientific terms, we can say that all energy of the universe compressed into a tiny hot particle, or into a tiny and dense point. So now, let's get back to the major question. If the Big Bang wasn't an explosion, then what was it? Here's the answer. There was a tiny hot ultra-dense point which was in the same state for a long period of time. Certain factors caused it to suddenly expand and to continue expanding. And the temperature also cooled down. So day by day, the temperature of the universe is also reducing. This sudden expansion is like an explosion and is referred to as the Big Bang. So here's the answer to what is the Big Bang. It is only a sudden expansion and not an explosion. Just like a balloon. A balloon remains in its normal state unless you blow in it. When you blow in it, it keeps expanding until you stop blowing it. Okay? So don't forget to drop a like, share, and subscribe to the Junior Astrophysicist. Have fun learning. See you guys. Bye.